last one of the unit before you launch into the project.
Actually, I lied. There is another lesson. It's on spreadsheets, but you'll do that after the quiz. Here we go. Standard deviation. Dispersion is what we're measuring today. That's what that does. What is dispersion, Mr. Larson? Such a fancy word. It's just spread. So how spread out are the data? And we're going to do that with a single number. So one number reports to us the standard deviation. All right, we're going to start off by looking at these two sample sets of numbers. All right, here we go. Look at the first one. What is sigma? What is the sum of those numbers? Add them up. All right. 1 plus 9 plus 8 plus 2. Okay, I got 25. Is that what you got? How many items are in that set? 5. Which of those values is the middle value? Well, remember there's like n is 5, so 5 divided by 2 is 2.5. So we're going to look for the third item in the set, right? Which you can see the middle item is 5. How do I find x bar? X bar is the mean, is the average. So take the sum divided by how many there are, and lo and behold, we get 5 again. Wow, we've got 5 3 times. Range, high minus the low. 9 minus 1 is 8. Mode, which number shows up the most? Well, there is no most, so there is no mode. All right, I'm going to do that again because it was so much fun, but with this group. Pause the video, find those values for that group. All right, and you're back. 25, 5, median is 5. 25 over 5 is 5. Range, same thing. No mode. Okay, boom. We look at these summary datums and we say, oh, look at that. That and that are almost identical. In fact, I don't see any difference. But I look at my two sets and I say, are these sets the same sets? And you go, well, there's similarities. They both have a 1. They both have a 9 and a 5. But this has a 6 and a 4, and that's got a 2 and 8. So no, they're not the same set. Well, why the heck are we getting the same summary data set? Well, that is because we haven't measured the standard deviation. If you would just measure the standard deviation, Mr. Larson, you would see that these two sets are spread out differently. To do that, I'm going to show you a dot plot. Dot plots are really easy to make, and they do show you spread. So this first has 5 items, 1, 2, 5, 9, 8, and I'm just going to take those 5 numbers, and I'm going to put them down here as dots on my number line. It's called a dot plot. All right, so here goes 1, and here goes 2, and 5, and 8, and 9. Okay, fine. Now let's do it for the other set. Again, the other set again was 1, 4, 5, 6. So 1, there's 5, 4 is just to the left, 6 is to the right, and then 9 is out here next to 10. Okay, so again, here's 0, 5, and 10. All right. Well, I can see now that these graphs are different. These have points which are on the grouped towards the end, whereas here, they're all in the middle. Okay. In fact, if I were to say which graph down here does this resemble, you would say, well, it resembles this guy. Whereas this one here resembles more this guy, or maybe this one. What does this mean? Just like the range, yeah? The range, if you measure dispersion or spread, do you remember that? Range, high minus low, how far apart are items? If there's a large range, that means they're spread out a lot. So if my standard deviation is high, that means they're spread out a lot. But if they're close together, then the range is small. So this one has a low standard deviation. The range might be the same. This one has a high standard deviation. And this one has what we would say is a meh standard deviation. It is neither high, it is neither low, it is somewhere in between. Okay. Again, we are looking for how far is something from the middle. Yeah? So this has a lot of items from the middle, whereas this, even though they're spread out, they're kind of near the middle. And here we have, obviously, everybody is near the middle, except for these people here. All right. Turn the page, calculating standard deviation. Hurrah! Toughest thing you'll do, I think, in this course mathematically. We give it a symbol. Yes, kids, new Greek letter. This is lowercase sigma. We just say sigma. There's no, and yeah, sorry, this is uppercase sigma. I don't know why the stats gods did this to us, but they did. So this means, again, sum, and then this guy is the standard deviation. Now, just like x bar and mu both refer to the mean, the average, yeah? Sigma is kind of the Greek letter, but sometimes, especially on calculators and softwares, they'll use the letter S, and this is what refers to the standard deviation. So this or S are two different ways to shorthand standard deviation. What does it measure? It measures how far the data is from the middle. The middle being the mean. Now remember, when data is centered, the mean and the median are together in the same spot. So this here, x bar, or the mean, is the median in the middle. All right, and the standard deviation measures how far apart. Now, without getting too complex, what I'm going to say is that in this graph here that I've drawn, the standard deviation would be about there. I'm eyeballing it, okay? And this distance here from the mean to what we would classify as the first standard deviation, this is sigma. This is the distance that we're looking for. How far apart is that? Well, if the data set is like this, right, and your middle is here, and your first standard deviation is here, now that standard deviation is huge, right? Because it's that much further apart. Okay. How do you calculate it? Here is the formula. And here we go. Number one, we use a square root. Okay, this is on your calculator, it's a button. Practice it right now. The square root of 16 should give you 4. Do you know how to use that button? I hope so. All right, so here we go. You are going to add up a bunch of stuff. In fact, not just any stuff, you're going to add up squares, meaning you're going to take something times itself. All right, what stuff am I going to add up? Well, before you square it, you have to subtract 2 x's. What x's am I subtracting, Ms. Larson? How fascinating. I am subtracting the data item. I'm going to call the data item xi minus x bar. Now, you should remember that this means the mean, x bar. This is the data item. So if you look down here, I have 5 different data items. I need to subtract each of them from the mean. I'm going to square it and then add them up. Oof. Yep. That's why you're only doing like 3 problems for homework, or 2 standard deviations is all you're actually calculating. All right. Then before you take the square root, you have to divide by n minus 1. And I know that most of you would have been happier if I said just divide by n, because remember when we find the mean, how do you find x bar? You take sigma divided by n. And I know here we're dividing by n minus 1. And again, higher mathematics, we can talk about why the minus 1 is there. I don't want you to worry about that. Know that it's just 1 less than n. Enough. off we go. Here we go, group A and then group B. These are from the other side, same sets of numbers. I have over here on the left side the steps that will help you remember how to do that. So, step one, you got to find the mean. How do you find the mean? Well, you need to know sigma, 25, we did this, n is 5, so 25 divided by 5 is 5. If you don't get a nice number like 5, just round it off to 5 point whatever and use that, okay? All right, now I'm going to say what is the difference between each of these numbers. So I'm going to subtract 1 minus 5. I'm going to write 4 because I'm not going to worry about the negative. 2 minus 5, 3. 5 minus 5, 0. 3, 4. Notice how we have a set of numbers that got smaller and then got larger. We will not usually get the same values on either side. Okay? You will in this example because I set these problems up to do that, but that won't necessarily happen. What is the square of each of these numbers? Now be careful, that's different than the square root. Square root means you multiply by itself. So what is 4 squared? 16. 9. 0. 9. 16. Again, we notice a pattern. It's large and then gets smaller and then gets large again. Now I need to add up those numbers. What is the sum of these numbers? That's what sigma says. 25. Now I need to take the 25 and divide it by n minus 1. Whoops, that's not 25, I lied. That's 50. Good catch, people. So 50 divided by 5 minus 1. Oh, 50 divided by 4. 12.5. What is the square root of 12.5? I think, I'm going to grab my calculator. Second square root. Always hard to find on a calculator. Of 12.5. Okay, I got 3.535. So I'm going to round that off to 3.5. Okay? All right. Go through and do it again for group B over here. Same process. See if you can end up with 2.9. All right? Go ahead and pause the video while you find that second standard deviation. Make sure you know how to find that. Keep in mind, the first thing is that you find the average, aka the mean. Then you divide. Then you take a square of each one. You add them up. You divide. Whoa! You do not divide. You find the difference. That's what I did there. Then you divide. Finally, you take a square root. Not a root. All right? So that's what we did in each step there. Again, do it in group B. See if you can get 2.9. Pause the video, and then we'll come back and finish. All right, what we notice here now at the very end is that 3.5 is bigger than 2.9. So we can say that group A has the larger number. So it's dispersed more than the standard, then is dispersed more because the 3.5 is bigger than that of B, 2.9. Okay, so they're spread out more. And you could see that if we go back to the graph. Remember the little dot plots that we made back here? The dot plot is more spread out here than it is here. So that's what that number is showing us, 3.5, 2.9. All right, best of luck in your homework.